Okay, and my name is Remy Dupart, and I'll be working with you on energy, work, and power. Okay, so the formulas used like in this section are the kinetic, which equals 1/2 of mass times a velocity squared, and power, which equals work over time, and work, which is force times distance, and a potential energy, which equals mass times gravity times height.
I have to look.
Okay, so a dog pulls a 40 kilogram
Putting it
wagon
like this or like this when it was straight?
with a force of 300 Newton over a distance of 50 meters. So, how much was done by the dog? Okay, so for this, we're gonna have to find what's hidden. Okay, so we have the mass, which is 40 kg. We have the distance, which is 50. Okay, so now, now for this problem, we have to find work. So the formula we have to use is work equal force times distance. And also sensing that force is 300 newtons. So now for this, we plug it in. Work equaling 300 Newton times 50, which would then equal 1,500 joules, which means that the work done by the dog on the wagon was 1,500 joules of energy.
More.
Okay, so another problem we'll do will consist of a 2,800 kilogram car exerting a constant force of 20,000 newtons while traveling a distance of 50 meters. And now we seriously must find how much work is done by the car. Okay, so we must now list what we have. We have mass, which is the 2,800 kilograms. We have force, which is the 20,000 newtons. And we have the distance, which is 50 meters. And so now again, we seriously must use work equation to find what we're missing. So now we plug in force, which is 20,000, and the distance, which is 50. And so then this will give us a work of 1 million joules of energy done by the car. Okay, and so now one more little common fact is that all of these equations, the kinetic, work, and power, they all equal each other. And because of their common interest in the joules spectrum of energy,
I want to live, Jason.
Which is what each gives off when which is what each gives off in terms of science.